Okay. We left off with a number, 923.35. That's the value that I came up with for sums of squares between the groups. The next thing I did is calculate the sums of squares within the group. Now here, we're going to do this, sum of, and then bracket. We're going to do this, what's in this formula, or what's in these brackets right here, we're going to do that for each group and add it together. So this is the sum of x squared minus the sum of x squared divided by n for the group. So that's again why you see 1, 2, 3, 4 portions to this equation, because we're doing that for each of the 4 groups. This is the sum of x squared for group 1 minus the sum of x squared for group 1 divided by 5, the n for group 1. Then we're going to add that result to the sum of x squared for group 2 minus the sum of x squared for group 2 divided by n for group 2 plus the sum of x squared for group 3 minus the sum of x for group 3 then squared divided by the n for group 3 plus the sum of x squared for group 4 minus the sum of x for group 4 squared divided by the n for group 4. So again, we're using these terms. That's why it's very important to make sure that you are referring to and using the right numbers. We're doing each of those numbers, the sum of x squared, the sum of x squared, n for the group, doing that for each group, carrying the math through. And I came up with a value for SS between sums of squares, within sums of squares within the group of 2009.2. Now the next thing I did, which is also why it's important to calculate SS subtote, it's a nice math check, as I've referred to in previous YouTube clips. If we did all this correctly, SS between and SS within, adding those two groups together, sums of squares between and sums of squares within, should equal sums of squares total, and indeed they do. 923.35, that's what I got for SS between, plus 2009.2, that's what I got for SS within, adding those two things together, and I get a value of 2932.55. That is, that's what we started with after we did our initial calculations. Next, we're getting very close. Find MS, which is the total raw between group variance, MS, which stands for mean square between. Mean square between, we need to find mean square between by taking SS between and divided by DF between. And as hopefully you know by now, DF between is k minus 1, or the number of groups in our analysis minus 1, in this case 4 minus 1, which is 3. So we simply took our value that we got for sums of squares between, divided by DF between, and came up with a value of 307.783 for MS between. That is the total raw amount of between group variance without accounting for within group variance yet. Okay? So the next thing we need to do is calculate MS within, mean square within the groups. To find that, hopefully it makes sense that you would take SS within, which we just calculated, divide by degrees of freedom within. As a side note, degrees of freedom within is n subtote, or the total number of cases involved in our analysis, minus k, the number of groups. So in this case, that would be 20. There's a total of 20 cases involved in our analysis, minus 4 groups. 20 minus 4 is 16. So as you already know, we found for SS within, we found a value of 2009.2, divide by DF within, which is 16, to come up with a value of 125.575 for mean square within. We're really close now. To find data generated F, which means in order to find the true amount of between group variance after accounting for within group variance, right? To find the true amount of between group variance after accounting for within group variance, all we have to do is take what we found for MS within, divided by, MS between divided by MS within, mean square between divided by mean square within, and I'm just substituting the numbers I found earlier. 307.783 divided by 125.575 is 2.451. After all is said and done, that is our data generated F value, 2.451. That is the true amount of between group variance. That's how much those four groups differ together after taking into account how much they vary within one another. So there are 2.451 units of true between group variance. Well, the only thing left to do at this point is to put that value to the test. Is that a lot? Is it a little? I don't know. Let's find out. Here, seen this before. I drew the F probability distribution. It's only got one side because there's no such thing as a two-tailed test with F tests. It's simply things either vary or they don't. There's either difference between the groups or there's not. There's no such thing as negative difference. There's no such thing as negative variance. We were asked originally to test this null hypothesis at the 0.05 level, so I drew my probability distribution. I marked the tail. I indicated the size of the tail. That's our critical region. The size of our critical region, 0.05. That means this portion here has to be 0.95 because these two pieces together have to equal 1 or 100%. I then indicated my legend. Degrees of freedom between is k minus 1, or number of groups in the analysis minus 1. In this case, it'd be 4 minus 1, or 3. Degrees of freedom within, n subtote minus k, the number of groups. N subtote is 20. There were 20 cases total involved in the analysis, minus 4, the number of groups. 20 minus 4 is 16. So we've got 3 degrees of freedom in the numerator, 16 degrees of freedom in the denominator, and we were asked to test this null hypothesis at the 0.05 level. Given all this information, I then turned to the F table in order to find the tabled F value, which in this case is 3.24. That number is the maximum amount of between group variance we could expect to occur by chance alone given these conditions. Again, 3.24, that came from the table. That is the maximum amount of between group variance we could expect to occur by chance alone given these conditions. How much between group variance did we actually find? 2.451. 2.451, that's the amount we actually found. Well, where does 2.451 fall on this drawing? It falls right there. It did not exceed the tabled F value. It's down here somewhere, which means it did not fall in the critical region / rejection region, did not fall in the rejection region. Therefore, we retain the null hypothesis. The amount of between group variance we observed, 2.451, the amount of between group variance we observed could reasonably be expected to occur by chance alone, chance or sampling error alone. The four groups, freshman, sophomore, junior, senior, are equal regarding the amount they work outside of school. Now, they're not equal. They do differ from one another, but they don't differ so much as to warrant rejecting the null hypothesis. The amount that they differ could be attributed, as you saw in the handout, could be attributed to chance or sampling error alone. So the difference we observed was trivial, so to speak. And that's that. I hope you found that beneficial, and I hope that all of that, the clips for this week and a couple weeks ago, right, before break, will help you in conducting your own F tests, drawing the right conclusions, and then making the right, and then explaining them appropriately. Please be aware that it is important to make sure that you indicate what things mean. It's not just simply enough to say, and I've mentioned this before, so hopefully it won't come as any sort of surprise. It's not just enough to say we reject the null hypothesis. In fact, I would argue that it's probably not enough to say we reject the null hypothesis, we observe more between group variance than we could expect to occur by chance alone. That's good. There's nothing inherently wrong with that, but it doesn't show true understanding. What does show true understanding is what I tried to display briefly and simply in a straightforward manner, but simply saying, bringing it back to what we're analyzing. The four groups are equal regarding the amount they work outside of school. That's what we were asked to test in the first place, whether or not we should retain or reject that null hypothesis of equality.